teacher development, including the use of improvement science to change instructional practices in mathematics, leading to improved graduation outcomes. She draws upon her prior experiences as a teacher, instructional coach, and statewide mathematics content specialist for Massachusetts to provide technical assistance to teachers, helping them focus on making math accessible and enjoyable for students of all backgrounds and abilities. So I'm very much looking forward to hearing Dr. Griffin today and to work with us, and I will mute myself and turn off my mic. Melinda, we can see you right now, and to conserve bandwidth, we're encouraging everybody to consider turning off their video cameras as well, so that there's the least drain on the system for those who are with slower connections. All right, so thank you and welcome.
Sounds good. Thank you, Catherine. And hello, everybody. I'm going to say hi on camera, and then I'm going to go off camera because the slides are a lot more interesting than looking at me for the next hour. So I'm glad you all are joining me this afternoon. I'm going to pop off for now, and you should still be seeing the screen from me. So as Catherine said, I'm a researcher here at American Institutes for Research, but I'm proud to say I'm a former teacher and instructional coach, and one of my favorite parts of my job whenever I have the opportunity to get out and actually talk with and work with teachers that are in the field, because you all are precious to me. So it's great to be with you all this afternoon. So today we're going to be talking about instructional routines. So we're going to be defining what an instructional routine is. We're going to think about ways that instructional routines are useful for teaching math. In particular, identifying some math processes that can be developed using an instructional routine. And I want you to consider ways that you can incorporate some of these instructional routines with your students, either the ones that we're actually going to look at together today, or hopefully this will trigger some ideas of your own for things that you want to do with your students. So let's kick this off by thinking about what a routine is. In very basic terms, it's a sequence of actions that we regularly follow. And people tend to think of routines, particularly in the morning. If you're an adult, coffee is often a necessary way to start the day. We often think, if you have younger children at home, of bedtime routines, because this is, by getting those children to bed, you get a chance to relax at the end of the day too, and perhaps go into your own bedtime routine at that point. So routines serve to provide a flow for actions, and they're really a structure for time and interactions that occur during our life. Now, often we will say that routines become something that just happens, so they run on autopilot. I think of this sometimes if I'm driving and I just automatically make the left-hand turn like I would be going to the office, even though I really need to go to the grocery store where I should be going straight. So sometimes routines become autopilot, and that's not necessarily a bad thing. It can be a really good thing, particularly where your students are concerned. So we have personal routines, and then we have what I call classroom routines. My take on this is classroom routines, particularly in a K-12 setting, allow teachers to survive 180 days with students who seriously outnumber them. But in any type of setting where you have a lot of people in one place and you need to get things, there is some type of routines that are in play there. Now, sometimes we want to think of routines as procedures, but a routine is often made up of several procedures that we follow. So procedures are kind of a subset of a routine. All right, so that brings us to what we're going to be talking about today. So what is an instructional routine? And I would love to hear from you your thoughts on this before we start digging it in together. So if you would, use your chat box over to my right, perhaps your left, and let us know what you think about instructional routines. All right, let's see here. All right, so yep, procedures come in there definitely. An agenda definitely helps. Oh, I like that one. System to utilize with students. like people are using them, and their students like them even better. And I always say sometimes we crave novelty, but then we miss routine when we get away from it. And this can be true in the classroom as well. Consistency. That's a good one too. I like that idea. All right, so some great ideas out there. That idea of giving students structure and safety has come up as well too. Students may feel more safe in a classroom as far as what they can do mathematically if they have a routine in place. So these are all great ideas to start with. So let's dig in a little bit more to this now. So instructional routines in the research aspect of this are specific and repeatable designs for learning. And they support both the teacher and the students in the classroom. Sometimes we think of them as only benefiting students, but they help you out as the teacher too. And it engages all of our students to be more fully present in learning opportunities while building those crucial mathematical thinking habits. And we're going to talk about that quite a bit today when we get into some of these routines together. They structure the relationship between teacher and students around content in ways that consistently maintain high expectations of student learning while adapting to the contingencies of particular instructional interactions. So I think this tends to speak to, you have a routine, but routines aren't set in stone and they've got some flexibility to them. So depending on which group of students you have in front of you on a particular day, you can make some adjustments to a routine to make it more accessible and usable by the students that you're with. So if we want to come up with some more concise definitions for these, we can think of instructional routines as designs for interaction that organize classroom instruction. And one of the great things about them is a really well-designed instructional routine is going to open up conversations and thinking about mathematics that might not have just happened on its own. So I hope I've convinced you all at this point to use instructional routines. So let's keep moving a little further with this. Now, it looked like some of you were already showing a little bit of this before, but I want you to think about your own instruction with your students and tell us a little bit about what instructional routines do you already use with your students when you meet with them. Yes. Morning greeting, I like that. Oh, problem of the day, awesome. They're very good for review, that's true. That's nice, so kind of a lead in to let students know what they're going to be learning for the day. Daily warm-ups. I always liked, when I was in the classroom, using a warm-up with my students because they would come in and they would know what to expect. It also freed me up to do some of that greeting of students, which is really important too, which I'm seeing some of you mention here for the day, is acknowledging and welcoming your students into that classroom with you. All right, a schedule. That's a good point too. An instructional routine can have different components to it. So some may be written and visual and some of it may be verbal going on. So this looks good. A lot of people use warm-ups. That's a good way to get things started. All right, so let's think about the math classroom in particular. So when I'm teaching math, I kind of have two things going on at the same time. So I have content that I need to teach, and content tends to organize into different domains within mathematics. So things like number sense, we have geometry. I particularly like these definitions from Ontario, actually. So that idea of data management and probability, often it's called probability and statistics here in the States, but to me this is a much more encompassing definition of what that is. Patterning in algebra is a big one too. We start with kids when they're young, but we want, even as adults, there's still a lot more to learn around that. So we have that content that our students are learning. And in tandem with that, we want our students to develop some processing skills. So I always think of like, these are the skills that help you do math. So these are the ones from Common Core Math, but I like the way that they're stated. So that idea of making sense of problems and persevering in solving them, to me, like this applies in the math classroom, but it applies just to life in general too. Being able to reason abstractly and quantitatively. So if I'm a student, knowing when can I take something in context and pull it down and mess around with it abstractly in the world of mathematics, but then take it back out to the real world and have it make sense. A really important one for students is constructing arguments and being able to critique the reasoning of others. And the idea of modeling with mathematics. So these are all ones that we can definitely use with instructional routines. The last two I like a lot for this as well. So look for and make use of structure, and look for and express regularity in repeated reasoning. So these tie back very well to that content area of patterning in algebra. And to me, these are ones where students really start to dig into the mathematical truths, I guess you could say, or like the nuts and bolts of what makes mathematics run. Because by the time our students get to algebra, we're looking at, if I can express something algebraically, I can provide a generalization about the mathematics that I can then use in many, many different situations. I'm not hemmed in by numbers like I did earlier. So if we can bring these two together with a routine, our students are going to learn a lot at that point. Now there's another factor that comes in here as well, motivation. So I can have the most beautifully designed content and I can have the will to do lovely process with it, but I need to make sure my students are motivated to engage with what we're going to learn that day. So consistently using instructional routines can increase students' motivation to engage with the math, because oftentimes a student may have a hard time seeing a path to success, but if they have a routine that they know they can follow, that gives some confidence as they head down that road. I feel like instructional routines also are an important part of equity with our students. So this is a statement from the National Council of Teachers of Mathematics. Particularly, this book is geared towards high school mathematics, in that mathematics teaching involves not only helping students learn concepts and develop skills and understanding, but also empowering those students to see themselves as capable of participating in and being doers of mathematics. So I always said my goal for students was for them not to just do math when they were with me, but then for them to be able to do math anywhere in their world where they needed to use it. And instructional routines can help them build that confidence to do that. So there's some good research behind this as well. This is funded by the Nellie Mae Foundation. So we know now that instructional routines definitely help to make a classroom more student-centered. Now, why would we want a classroom more student-centered? Because we know that if a classroom is more student-centered, that's going to help those students see themselves as doers of mathematics. So in this study, students reported being more engaged in how much they were learning and much more interested in the material compared to students in classrooms that were less student-centered. Higher growth on a test of problem solving after this. And we think from the research, a lot of this comes from that ability to not just work through mathematics computationally, but to be able to think about it and share that thinking with other people. All right, so let's move on and think about, if I'm going to use instructional routines in the classroom, where am I going to focus them? So we've got that content and process going on, and I'm going to generalize this beyond some of the domains and specifics that we saw before. So for content, I'm going to think around developing conceptual understanding and procedural fluency with my students. So these are things that could come into play with any topic that we happen to be studying. And it's also part of what we would term mathematical rigor. If we think about rigorous mathematics, not that it's hard and you don't like it, but that if it's rigorous, I have components of conceptual understanding and procedural fluency married with applying those things in a contextual situation. And that could be a real world situation that students might encounter, or it might be a mathematical situation, but there's some context there with it, to where I have to think about, what do I know about the situation, and what do I know how to work with in this situation, and bring all those things together. If I think about processing skills, we had that list of 8 things previously, but I'm going to distill that down a little bit further to 3 areas. So the idea of being able to solve problems, being able to communicate my thinking to others. So particularly if I'm solving a problem, can I tell someone else what I'm doing and why I'm doing it? And then argue and evaluate. And argue and evaluate goes even a little bit deeper than that. So let's take a look at these. Whoops, a little bit more depth. Now this comes from work I do with some schools in Florida they're working to improve graduation outcomes for their students. And one of the great places to start is with mathematics. So if I think about conceptual understanding, we've defined this as comprehensions of relationships and connections among concepts and procedures. So it's not only understanding one thing, but it's understanding how it connects and relates to other things in mathematics. For procedural fluency, we think of this as the knowledge of and the ability to perform procedures flexibly, efficiently, and appropriately. So in other words, procedural fluency isn't just knowing the algorithm or the steps in a process that I want to follow. It's knowing which one of the procedures that I have in my toolbox I want to pull out at that time and marry to the problem that's in front of me. For my process skills, solving problems is understanding the problem, attempting and persevering at solving it, and then making sense of the solution within the context of the problem. Now, the last 2 follow very closely together. So communicate thinking is a student creating coherent explanations, particularly using precise language and representations if they can. Now, the word precise to me doesn't mean that that always has to be the absolute correct academic mathematical term that you would find in a textbook. But it means that when the student goes to explain something, the language that they're using is consistent and precise to the situation that they're speaking about. Same is true for representations. It should be accurately depicting what they are explaining to you. Argue and evaluate goes a little bit beyond that. So communicate thinking is coming from the self, the student is self. Argue and evaluate is moving beyond that to thinking about how others consider something, as well as how something fits into the structure of mathematics itself. So this is really making sure that instead of just telling you my thinking, I can actually present it using a logical thought or argument that justifies why I'm doing what I'm doing. Okay, so let's move on and take a look at some of these in action. So I'm going to start with create coherent explanations using precise language and representations. And I'm going to pause here for a minute because I'm not seeing my chat box come up. And I'd really like to know if there's things going on.
So Melinda, if you click on the more button, is it not coming up?
I see chat there, but when I click it, there's no pop-up like there should be. It was doing it earlier, but now it's like not there.
Okay.
So just feel free to jump in, Vicki.
Okay. All right.
How's that?
Will do. Thanks.
Vicki is now my chat, which is an awesome thing. So, y'all don't get to see me like trying to like focus on the screen and look at the chat box at the same time.
No problem.
I'm always very, you know, my kids can handle this, I can't. But so we're going to look at some routines together. So let's start by thinking and communicate thinking. So that's creating those coherent explanations using precise language and representations. Now, as you head into this, And as we look at this routine and as you start thinking about routines that you can develop on your own for the classroom, I think this is an important process to consider scaffolds with. Because some of our students want to communicate, but they're not sure how to get going with it. So some good scaffolds to consider are sentence starters. In other words, they give kind of like prompts leading into what a student is going to say. Like, I consider blank is true because blank, those type of things. I have something here called a word wall, and wall is in quotes because a wall is not just a physical thing. So this could be a list that students have of terms that you're using in the unit of study. It could be something that perhaps is on an assignment that they're going to refer to. So if they're doing an assignment and you want to use a routine with it, you might provide vocabulary that's specific to that assignment. It might be things from students' notes that they can look at to understand the vocabulary that you need to talk about mathematics and what you're studying. Some other scaffolds you might think about are graphic organizers for your students, which teachers tend to use pretty regularly anyway. As we look at routines, thinking about sometimes you can create a graphic organizer to go with a routine that's going to make it more accessible for a lot of your students. And sometimes students just need written directions. In addition to the verbal directions we give them, it can be really beneficial to have something written in front of them that they can look back at and refer to as they move through the routine. All right, so we're going to do a little math together. And this is a routine called Which One Doesn't Belong? Okay, I've got the website there at the bottom. This is a great site as a teacher to go take a look at on your own and just see some of the stuff that's out there that you might be able to pull and then use with your students. So here's the routine. I see these 4 things here in front of me. If you're old enough to remember Sesame Street as a kid, there used to be that song, one of these things is not like the other. That's kind of what we're going to be doing here. So I'm looking at this example. There's 4 numbers here. There is a way that they belong to each other, but I can also make a case for each one of these numbers for why it doesn't belong with the others. So that's what I want you to think about right now. Take a minute and see what you can come up with as far as which number doesn't belong. Now, I'm going to tell you as well, there is not one correct answer to this. There are multiple correct answers. So if you come up with one reason, feel free to come up with more than one because there's plenty of them out there. And I'm going to try once again. My chat is there. Maybe it's because you all were quiet before, but it's back. So that's good. Okay.
Perfect.
Okay. This is good. This is good. See prime numbers being mentioned, that idea of perfect squares. Odd and even. Okay, these are good. Ooh, Fibonacci numbers. I like this one. This is one you would probably get from kids. 7 and 9 are the ages that you don't have a driver's license, whereas 16 and 25, you could get one. Ah, good, good. All right, so you all have some great responses there. So let's take a look at some possibilities for this. Okay, so I saw a lot of responses around 7, and there's a lot of reasons for 7 in this case. If I think about the other 3 numbers, I can sum 16 and 9 together and get 25, right? I saw prime come up a lot, and 7 is not a square, whereas everything else on here is. For these other numbers too, right? So 16 is the only even number that I see up there, okay? 9 is the only number whose sum of its digits does not equal 7. That's something you don't necessarily see right away. You have to take a little thinking about it. And they said 25 in this case because 7 plus 9 is 16. So I think your students will enjoy this. There's a lot of different possible answers with it that you can look at. Okay, so we did one with numbers, but you can also use this for spatial reasoning as well. So this is an example that has a little bit more of a geometric base to it. So if I look at these 4 figures, I could say something even as just visually basic as the square up in the upper right-hand corner has a checked pattern to it, and everything else is just solid white. Or I might say in the lower left-hand corner, that square is sitting on a corner and everything else is sitting on a base. Depending what I'm studying in geometry, your students might say, well, 3 of these figures are quadrilaterals and the one figure in the bottom left is a pentagon, so it has 5 sides. I also might look at it and say, okay, if I look at the one in the upper left-hand corner, that's a rectangle. The other 3 shapes all have congruent sides, and that one does not. So there'll be a lot of different ways to come at this with spatial reasoning as well. So to me, a good instructional routine is content agnostic, meaning that it's a routine that can fit with a lot of different topics that you might be teaching. And the idea of it being routine is something that your students get used to doing too. So here's just some other examples. We could use this with equations. So if I'm looking at equations or functions, I can start thinking about the differences between these. If I'm talking about similar triangles and things in a geometry class, here's some examples of how that might look with a geometric figure. This one's a little more formal than the one I looked at before. Or perhaps if we're starting to study slope and the idea of slope and what's a linear equation, the one on the right that has graphs could be an interesting way to think through this. And I'm going to throw one more in there just because I think this one is cool. So it doesn't necessarily have to be a math thing. So this is one with maps. And once again, thinking about which one doesn't belong. So like when I look at these, I see 3 of them are actually showing public transportation systems. Whereas if I look at Los Angeles, this is showing me the freeway system for cars as opposed to public transit with bus or a subway. So lots of different possibilities here. All right, so let's take a second. And I want you to think about how you might use this with your students. I always say it's great if you can attend something and take away something you might use next week. So maybe even think about something you have coming up that you're going to be teaching and how might you use this with your students. And if you want to share in the chat box, we'll take a minute or 2 and have you share out as well. Multiples, that's a good one. Yep, hook them in or have them look at it before they leave. Those are great places to use this. Yeah, someone said start with shapes and then work their way up. I think that's always a great approach with instructional routines, is start with something basic that students don't have to worry too much about the math in it, and they get to focus more on the routine itself. And then you can ramp it up from there. A discussion starter, I like that one too. Okay, so someone asked, this is a good question, how often would you change the routine? I think it's going to depend on what you're teaching. You're going to see as we look at some of these, there's some routines that are going to just fit better or feel more comfortable with some topics than others. So that to me is often a way you decide when to switch things up. There's some routines, as people are kind of commenting here, that work well for closing an instructional session. There's others that are going to work better in the middle of an instructional section. And then I think you also look at routines. There are some routines that work well when you're introducing new material to students. And there are others that you want to use with students when they've already learned something about a concept or topic and you want them to do some practice with it. All right, so let's move ahead. So this is one of my favorite part of instruction routines is you have a routine, and then once everybody's familiar with it and comfortable with it, you can start riffing on it too. So here's a takeoff on which one doesn't belong that we can call incomplete set. So before we saw a figure and all 4 of my quadrants had something there. In this case, I would give students an incomplete set and say, I'd like you to provide another item that could be both the item that doesn't belong, but that also completes the other set. So in other words, it has to belong, but also be able to not belong. So as we saw before, there are not going to be one correct answer for this. There will be multiple possibilities. And this is always fascinating to me, is to see how my students' minds are thinking at this point. So in this case, I looked at this and went, okay, if I look at the 3 figures I was given, I see a hexagon in each one of them. So I'm going to think about another item that has a hexagon in it somehow that can help complete that figure. And so I came up with a hexagonal pyramid. So it has a 6-sided figure, a hexagon in it, just like the other 3 do that I see there. But it also has an apex at the top, and the other 3 don't. So that's the one thing that makes it doesn't belong to the other set. So you could try this with your students, see what they come up with. Another thing you might think about when they're really familiar with this too, and I would maybe do the coming up with the 4th quadrant one before I would go to this one, is writing your own. So this could be a challenge either for you or for your students. So writing your own, you're going to have some guidelines that you need to follow. So you need to make sure when you come up with this that all images are likely to be chosen. In other words, they all have something that someone could see. That may take a little longer to see it, but something that they could see that would cause them to choose that particular figure. Each image also has to have a reason for not belonging. Okay. And when you do these, you want to think about gauging this at an appropriate level of challenge for your students, and you want to keep it interesting. So something that you want them to be able to respond to and engage with. Now this can be really fun to have your students come up with these too, and they'll enjoy working on them with their peers when they have a chance. So if you have students writing this, and probably for yourself as well, to think through this ahead of time, is making sure your students create an answer key in their mind that goes with this. So if I have a student write a which one doesn't belong, I'm going to ask them, in addition to presenting me their images in the 4 quadrants, to be able to tell me for each one of those images, why does it belong and why doesn't it belong? And that's going to help me see how they thought through the process as well. Plus it helps them see that if they give it to someone else, what might they get back as a response from other people that decide to use it? All right, so we've talked through one on communicating thinking. So now I want to move on and talk about argue and evaluate. So remember, the difference between this and communicate thinking is this brings in that idea of logical thought to create a mathematical argument or justification. So in other words, something that works within the laws of mathematics, and it's not necessarily just my thinking about how to do something. And as part of this too, being able to evaluate other arguments or justifications. So there's a lot of different routines around this, because in a student-centered classroom, this is often something that we want our students doing, is being able to create logical justifications on their own and be also able to critique someone else's work. So I often will see teachers do this using a routine that involves error analysis. And that's a really great way to do this, where students are examining a worked problem together, and then they either have to make a case for whether it's correct or incorrect, or sometimes they know that there's an error in it. They have to find the error. So that is a great approach to an argue evaluate routine. But we're going to look at one a little bit different today. So this one is called worked example pairs. And this is coming at it from another direction. So what if I compare two work samples and they both got the problem correct? How do I argue and evaluate about something like that? So here's the routine we're going to follow. I'm going to present students with a problem, and it's going to be solved in two different ways by two different students. And both of those students got the correct answer. So then I'm going to ask my students to answer these questions individually. So I'm going to give them some time to think on their own. How did each person solve the problem? What are some similarities and differences between the two approaches? And why did they get the same answer, even though they solved it in different ways? Okay. Now, if you can, take this routine further and have students, after they've worked individually, have them share their thinking with a partner. Now, partner is, once again, a nebulous term here. The partner could be you, it could be another student with them. It could be sharing their thinking in written form, whatever happens to work for your situation. Ask them to use these discussion prompts, because this is going to help move them away from just procedures to actually thinking about why something is happening. And then if you have a chance, have them share out with your whole group. So these are adapted from a study at Harvard University on contrasting cases. And if you go to their website that I have on here, you will be able to find a lot of examples that look like this. So in this case, we have students working through a linear system of equations. And we see Alex and Morgan talking about, here's the work I did. And they both got to the same solution. They both got a solution of x is 1 and y is 5. Okay. So questions that your students are going to think about as they look at this is, will this always work? So that's one thing to think about if I'm looking at a student's work. Did it just happen to work because the numbers were pretty? Or will this really work anytime I try this approach? And what is the underlying mathematics that makes this true? So in the case of something like a system of equations, it's that idea of balancing equations and being able to use some properties to manipulate equations to get them into the form that I need to find a solution. And how would I explain this to someone else? So if I've looked at this and I can tell why it works, how would I then tell someone else why this works or why it doesn't work? Okay, so interesting things to do. As before, you can move on beyond this as well and create your own. So like I said, the site at Harvard, if you go there, has a lot of examples you can just pull and use. But I think it's always interesting to look at them too and then think about ones you could come up with on your own. So you might try creating your own using just some different representations. So perhaps having one student's work shown with modeling and another student's work shown with just a numerical procedure that they're following. That brings up different strategies as well. So sometimes, particularly with like addition and subtraction, multiplication, division, there's a lot of different ways to go about it. There could be partial products, there could be partial quotients, there could be compensation and decomposition and all kinds of things going on. Thinking also about that numerical versus modeling piece. And you might also consider putting one in that has faulty reasoning. And like I mentioned before, that's where the numbers made it work in this case, but it won't necessarily work every time. I always think of the number 2 because the number 2 has the ability to do a lot of things that other numbers can't. If I add it to itself, I get 4. If I multiply it times itself, I get 4. And you often see when you move kids from additive reasoning to multiplicative reasoning that this is something that trips them up. So 2 is a good number to throw in there and see what you get. All right, so we're going to take a pause again for a minute. And I want you to think about how you might use an argue, evaluate type of routine with a lesson or topic you taught recently, or you might want to think ahead to something that you're going to be teaching in the near future. So let's take a minute and think about that. If you have a great idea, share it in the chat, because I always think you're going to learn a lot from each other and not just me when you come to these things. So let's take a minute and see what we get. Interesting. Quadratics. Yes. Substitute or factor. To substitute or factor. It's always like a Shakespearean question when you're doing algebra. Word problems, yes. I like that idea of order of operations in particular. So often students tend to think of, please excuse my dear Aunt Sally, and think that you have to do multiplication before division or addition before subtraction. You get completing the square versus the quadratic formula. A football field, I like that one too. Y'all have some great ideas. This is awesome. And the idea of having a student demonstrate, exactly. I always think it's great if you can have a student demonstrate and then have other students comment on or ask questions about what they've done in their work as well. So, great ideas here. I would say keep them coming in the chat box. I'm going to move on, but feel free to keep commenting over there. All right. So the last process we talked about was that idea of problem solving. So I'm going to do a little soapbox here before we get into it as far as what problem solving is. So problem solving is not just about getting the right answer, and it's not about just blindly following steps in a procedure. Problem solving is about considering what you know about a problem and thinking about what you know how to do and how it might apply to the problem that you're looking at. So when we're working with our students and helping them become adept at solving problems, this is my definition that I always strive for. So a good problem solver is someone who knows what to do when they don't know what to do. In other words, if they look at something, they don't know how to solve the problem, they know how to look introspectively and say, okay, does this look like a problem I've solved before? What tools do I have at hand? What do I know about the context of this problem? In other words, what am I seeing that can help me start to solve this problem? And then if I start solving the problem and I can tell something perhaps isn't working, then I know that maybe I need to shift gears and try something else. Okay, so that's our goal ultimately. So we're going to do a quick poll here and let us know, do you currently use a problem-solving routine with your students? All right, you all are quick on the button, which is good. I'll give it just a few seconds more. All right, so I'm gonna, can we end polling there, Vicki? All right. So it looks like a lot of you are using instructional routines around problem solving, which is great. And if you never have, that's why we're here today. So this is good. All right. So let's take a look at a problem solving routine. Now I saved this one for last because it tends to be the more complex one. Okay. All right. So here, if we think back to what we were talking about at the beginning, is kind of a definition I'm using for solving problems. So understand that problem, attempt and persevere at solving it, make sense of the solution within the context of the problem. Now, when you do this routine with students, I always have a caveat that I tell teachers, and that you want to be sure to choose a task or problem that's worth it. Okay, so in other words, it should be, we sometimes use the term a non-routine problem. In other words, it needs to be a problem that I can't just look at it and go, oh, here's the answer. It should be something I'm going to need to think about a little bit. And particularly if it's a problem in context, I might have to sort out some things in the problem to decide what it is that I'm going to solve. mentioned at the beginning that you do a problem of the day. So I'm going to work this routine around something called problem of the week. So I'm going to take that definition of solve problems and I'm kind of chunking it down into parts here of understanding the problem, attempting the problem, persevering at solving it, and making sense of the solution within the context of the problem. So by chunking this down, I can work on just a piece at a time of this with my students. So one day that I'm with them, I might decide, let's just do understand the problem. And then the next time I see them, let's attempt the problem. And the word week here does not mean you have to do it within the span of a week. It's just like when you have a chance to see them. And then I might actually have them solve it the next time. And then we might come back to it again and make sense of the solution. Or a lot of times I might want to pair these up where we understand and attempt the problem is actually making that plan to solve it. And then I might actually on another day have them solve it and then make sense of the solution and context. Okay, so this is what we're going to work for. And I'm going to marry this with a core routine, or we might even call it a protocol that I want students to follow as they go through this process. So I'm going to hand out the problem, make sure my student has the problem. As I go through this throughout the week, I might be handing them the original problem on the first day we do this, or I might be giving them back work that they've already done. I'm going to give each of my students 2 to 5 minutes of private reasoning time. I think this is always important, particularly if you're going to do an instructional routine where students need to talk to each other or talk to you, because it gives them a chance to think through it on their own. And it's kind of a little bit of private rehearsal time before they have to start going public with their thoughts. So then we'll have the student share his or her thoughts with someone else. And once again, this might be a partner, it might be a small group, it might be just you, it might be sharing their thoughts on paper, but some way to get on and out and publicize what they're thinking. And then they'll get some feedback. This could be from their partner, it could be from you as the teacher, it could be from the group, it could be from the class, okay? And then I'm going to give them a little time to revise or reach a group consensus on things. Okay, so I have my problem of the week. These are like the different chunks I'm working through, and this is the core routine or protocol that I'm going to use as I work through these. Now I need a task, and I have to admit that I am like the Bermuda Triangle of technology, so stuff goes wrong and you don't expect it. And sometimes I create my own technology problems. So in the problem that we see here, I corrected a typo and created another at the same time because that's how I roll. So the problem should read, Tanya sees a clearance rack at the store with a sign, I don't think it's a singing sign, on top that says, all items on this rack are 25% off. So she spots a cute dress that was originally $35. How much will she pay for the dress on sale? Okay, so here's my task or my problem that students are going to be digging into during this process. So I'm going to start with our first chunk, understanding the problem. And as students are doing their private reasoning time and then sharing with a partner, I'm going to use these prompts to help them structure what they're thinking about. So I want my students to think about, what am I trying to find out when I look at this problem? What information is given? In other words, what do I know here? Is there information I don't need? Is there information I need that's missing? And what should my solution look like? So when I look at this, and this is a good consumer math type of problem, I can look through this and say, okay, I'm trying to find out how much is Tanya going to have to pay for that dress. Like when she goes up to the cash register, how much she's going to pay. What information do I know? Well, I know that if that dress is on the rack, it's 25% off. And there's a tag on it which tells me that dress originally cost $35. There's not particularly any information I don't need, but that should be a consideration sometimes if you work with students who are not English proficient, and that words like clearance and originally and things like that can throw them off and might need a little extra explanation. Okay, and when I look at this, she's going to be paying with money, so my solution should be in dollars. Now I want my students to attempt the problem. So this could be the next day I hand back out their thinking on understanding the problem. I say, okay, what solution strategy should I use to solve this problem? And I might want to venture down the road of, is one method more efficient than another? And I'm going to speed up a little bit here because I know I'm getting close to time with you all. Okay. Now we're going to work at persevering in solving that problem. So students actually, they've come up with this plan of how to solve it, and now they're going to start working on it. And as they do that, I want them to think, how will I know I'm on the right track? And what should I do if I don't think my solution strategy is working? Then our last part of this, and to me this is part of the most important part of this, is does the solution I got make sense quantitatively? Does the solution I got make sense based on the situation I started with? I will always remember the young man in my class that told me the answer was a 22-inch bagel, because we were looking for the diameter of a bagel, and he said it's 22 inches. And I said, have you ever seen a 22-inch bagel? That would be a huge breakfast. And he said, well, the calculator said 22. So that also comes in terms with, does it make sense based on the situation I started with? And am I including units with my answer? So if I thought about inches, 22 inches is not going to make a lot of sense here. Okay, so as my students work through this and they get more proficient with it, then they're going to put all of these steps together, and this becomes a problem-solving routine for them. And you might be working this way already with some of the problem-solving routines you do with them. Our goal, if we go back to thinking about the original routines we have, is to have this become autopilot for our kids. Because if they have a problem-solving approach down, they're going to become more confident in solving problems. They're not going to freeze in the headlights when they see something that has words that they have to figure out. And it's going to give them that confidence to go ahead and try solving those problems. All right, we've got about 2 minutes left. Right, Vicki, am I on track?
Absolutely.
Okay. I won't talk too fast, but I'll speed up a bit. I'm going to just show this whole slide here. I think myth busting is important on this, in that oftentimes teachers may say, well, I don't know if my kids can do that, or I don't know if I want to try this in the classroom. So here's like some hints to get you going with that. Instructional routines don't have to be complicated. In fact, I think the more simple they are, many times the more effective they are. Just make sure you have some of that scaffolding in there where you need it, so that your students have good access to the routine and then the mathematics that comes with it. Some teachers may say, well, this is going to take a lot of time to do. I just don't have time for that. I'm already pressed for time. But a routine can be short or long, not length, depending on your purpose. And if you get a routine down and those students have internalized it, it can actually make your classroom move more efficiently. They're also not set in stone, as you've seen today. You can adjust them to meet your needs of your classroom. And in many cases, an instructional routine might just be an adjustment to something you're already doing that you decide to make a little bit more routine with your students so that they can get into it more. All right, this is a summary of what we've talked about today. Those routines are designs for interactions, and they help organize classroom instruction. We talked about content in the terms of conceptual understanding or procedural fluency, coming together with practices and processes such as communicating their thinking, arguing or evaluating, and solving problems. And instructional routines provide that framework that can be adapted and changed as needed so that they meet the needs of your students. All right, questions, comments, and thoughts? Go. No, I'm just kidding. We have the chat box still open. We're almost at time, but if you put things in there, we'll save the chat box, right, Vicki, where we can try to address some of these later if we have to.
Yes, absolutely.
Okay. Oh, Donna, thank you. Oh, sorry, it was a nice comment. So there will be a handout that has a lot of the slides that are in this. So there's a handout that's going to be available that actually goes through a lot of what we talked about in here. You'll also find a lot of the links that I mentioned in here to some of the resources that I used. So please be sure to take good advantage of those. All right, I know a lot of you have things to move on to for the day. So I just want to thank you all for being with me this hour. It was a pleasure to be with all of you. And thank you so much for what you do each and every day to help the young people of this world become better. So thank you all very much. And I hope I'll see you again sometime.
Thank you so much, Melinda. And thank you very much, everybody, for attending today.